Hello and welcome to my academy. In the previous lecture, we talked about the electron transport chain and oxidative phosphorylation. In this lecture, we are going to discuss about the chemiosmotic theory and ATP synthesis. Okay, without wasting any time, let us get started. The chemiosmotic theory states that the energy released from the electrons is used to drive the protons into the intermitochondrial membrane from the matrix. This action generates an electrochemical gradient for protons with a lower pH value outside the inner mitochondrial membrane than inside. The protons on the outside have a thermodynamic tendency of flowing back into the matrix so as to equalize pH. When the protons do flow back in the matrix, the energy is dissipated. Some of the energy is being used to drive the synthesis of ATP. Here we'll be more focused towards the ATP synthase or complex fifth. ATP synthase, it consists of two components, F0 and F1 component. F1 component of ATP synthase, it's made up of 3 alpha, 3 beta, gamma, delta and epsilon. At the center of the F1 ATPase is the gamma subunit. The gamma subunit is a rotor or moving unit. F0 component of the ATPase. F0 is a transmembrane complex that forms a regulated proton channel. ATP synthase synthesizes ATP by harnessing the proton motive force. ATP synthase can also function in reverse to hydrolyze ATP and pump H positive across the inner mitochondrial membrane, thus acts as a reverse coupling device. The protons in the intermembrane space have a thermodynamic tendency of flowing back into the matrix so as to equalize pH. ATP synthase, a transmembrane protein complex that uses the energy of H positive flow to synthesize ATP from ADP and inorganic phosphate in the matrix. Now we are going to discuss how ATP synthesis takes place. The binding chain mechanism is a widely accepted model of ATP synthesis. Paul Boyer developed the flip-flop or binding chain mechanism. ATP synthesis is coupled with the conformational change in the ATP synthase generated by rotation of gamma subunit. The ATP synthase contains three binding sites which interconvert between three conformational states as a molecule rotates. The diagram shows one stage of the active cycle. The three alpha beta dimers have three different states. In the stage first, the open state O is empty. The loose state L contains ADP plus inorganic phosphate, and the tight state T contains ATP. In the intermediate stage, bracketed rotation of gamma within the alpha beta hexamer converts L state to the T state, the T state to an O state, and the O state to an L state. The L state can accept a new charge of substrate. The T state can form ATP. When we look at the stage 2, the ATP has fallen out of the O state. New ADP plus inorganic phosphate have bound to the L state and the ATP has been synthesized in the T state. This completes our ATP synthesis. If you like the video, then do subscribe and share. Thank you.